Here's the next question, number 9. So the question reads, x of t is non-zero only for t lying between tx and tx dash. And similarly, y of t is non-zero only for t lying between ty and ty dash. Let z of t be convolution of x of t and y of t. Which one of the following statements is true? So we have our 4 options given to us. Okay. Now the key over here in this question is to understand what the phrase convolution is. Now by definition, you can consider the convolution to be, it is an integral that expresses the amount of overlap of one function as it is shifted over another function. So basically it is just a mathematical combination of 2 functions to form a third function. So that's what it is over here. X of t and y of t, the convolution of both of these functions to give us a third function, z of t. I hope that makes sense so far. So if we are to draw the functions, or to draw the upper bound and the lower bounds of the functions, let's start with x of t. So here we have x of t this way. We'll call this x of t here. And it is non-zero for tx and tx dash. Similarly, we can write down the graph for y of t. So for y of t, the function is non-zero at ty and ty dash. And we will have to find out what are the values, the upper bound and the lower bound values for z of t. So in this case, it is the overlap or the convolution of the 2 functions x of t and y of t to give us z of t. Now, the range of z of t, you will have to take note over here that the range of z of t would be the sum of the lower limits of x of t and y of t to the sum of the upper limits of x of t and y of t. Let me explain what I mean. I'm going to draw those 2 graphs once again so that it is a little clear. So if we consider this to be the first function x of t, okay, and we have our bounds as tx and tx dash, and then we have the function y of t, forgive my rough drawing, for the bounds ty and ty dash. Now in this case, the question tells us that the function is non-zero for tx and tx dash, and here for y of t, it is non-zero at ty and ty dash. So the convolution of both of this to give us z of t. Z of t. So, as I mentioned earlier, that the range of z of t is the sum of the lower limits of both these functions and the sum of the upper limits of both these functions. So that means that here the lower limit would be tx plus ty, and the upper limit would be tx dash plus ty dash, which means that the function is non-zero where t lies between tx plus ty and tx dash plus ty dash. This is our final expression for the convolution of both the functions. So let's see what this matches with. I believe it matches with option C. So this is our final answer. I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google Plus and Pinterest.